The analog to digital conversion is usually called just AD conversion. And what we do in this process is digitize the analog audio signal that is coming, for example, from a microphone or a guitar. So what we do in this process is just translate the information that's coming from here into, let's say, a language that a computer can understand, which is a binary, and that means ones and zeros. There are two main factors that affect this process, and it's the sample rate and the bit depth. And sample rate affects directly the frequency resolution. The bit depth affects directly the amplitude resolution. We're gonna take a little break just to remember what frequency is. So frequency just tells us how many cycles are there per second. So if we're talking about 1 hertz, it's just telling us that there's 1 cycle per second. Then amplitude, let's remember that it tells us how much is the signal compressing and how much is the signal refracting. Let's talk a little bit more about sample rate. Sampling is the process of taking discrete readings of various moments in time of a signal. So let's look at it this way. We have a signal right here, and we decide to make a measurement here, then here, 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 and so on. Let's think about each measurement as a snapshot. So what we're doing is taking little pictures or taking little pieces of the signal and then taking it to the computer. And then what the computer does is just get together all of these snapshots and play them back, just like a film or a video. In conclusion, sample rate is just the frequency in which these snapshots are collected. Now, sample rate required for digital audio is driven by a basic and fundamental theorem which is called the sample theorem, or it is also called Nyquist theorem. What this theorem is telling us is that in a given frequency of sound, each cycle has to be sampled at least 2 times. Now let's remember that the range of human hearing goes from 20 Hz to 20 kHz. Now the sample rate in digital audio, and according to this theorem, has to be twice this range of human hearing. So the sample rate has to be at least 40 kHz. That's an acceptable sampling rate, to get the full frequency audio. But most devices nowadays have a frequency of 44.1 kHz, like a CD, or 48 kHz. Finally, we're going to talk about bit depth, which, remember, affects directly the amplitude, which is usually perceived as the loudness of a sound. Now, the useful dynamic range of a speech in music goes from 40 to 105 decibels. And to capture this range, the AD converter has to be able to accurately represent these differences of amplitude of at least 65 decibels. Now, to capture all of this relative amplitude of a sample, what the AD converter does is it goes through a process called quantization. This just simply means that each sample is quantified or assigned to the closest available amplitude value. Now, to quantify a sample, the computer uses binary digits that are called bits. A bit is either a 1 or a 0. And the number of bits used to define a value is what we call binary worth. Okay, let's continue talking about the binary worth. And to know the binary worth length, we have to do this operation right here, 2 to the nth power. And okay, so usually under DAW, this binary word length is referred as a bit depth. You don't usually see this in your DAW, you see this bit depth. Okay, let's see an example. If we have a 4-bit binary word, that means that we have to replace a 4 right here in the end, and we obtain 16. So we can represent 16 values with this 4-bit binary word. So talking in digital audio, this 4-bit binary word means that we can have 16 discrete amplitude levels. This is just an example. In digital audio, we usually need something larger, So for digital audio, like I said, we need something like 24-bit. So 4-bit is actually not useful. So in conclusion, we want larger binary words because this helps us to represent in a much greater accuracy the amplitude levels.